We need to be able to monitor what the servers are doing, how they're doing it, the status of the network, and everything involved. We started in 2008 with 10 servers, now we're up to over 300. We have a mix of Asterisk 1.4 and 1.8, slowly moving 1.4 out of the mix, moving towards 1.8. And customers range in size of scope from a guy with 1 server to a guy that has 14. VGDial is basically what our hosted platform is using. It's, like I said, a large inbound, outbound, and blended call center platform. So the challenges with monitoring and a hosted platform is the clients often have little to no IT knowledge. If you're lucky, they can install Windows, install a browser, get it working. If you've ever dealt with an ISP or a carrier, when you have an issue, the first thing they say is, everything's great. Doesn't matter what's wrong, everything's great. So, I mean, they can't ping you, but everything's fine. You have to meet your SLAs, you need to be able to look at potential issues before they happen, so that way, instead of a customer calling you angry, the customer just never calls you angry. You need to be precise and reliable with your data. You have to be able to monitor the capacity of your system to know, okay, do I need to further my dimensioning guidelines? Do I need to add more servers? Can I take servers away? Can I aggregate things together? Do I need to split them apart? And the biggest thing is it needs to be robust and reliable. You need to have the abilities to look at things that may not be built into it by default, but also be able to scale it. It has to give you data that you can trust. So there's 3 basic approaches to monitoring. The first one is what everybody wants to do. It's basic service monitoring. Second one is where you're actually getting and logging performance and metrics, and you're using these to do like data mining on it to see how you're performing, how a client's performing. And a third one is angry customer calls, and I'm not kidding, that is an actual monitoring solution. Don't recommend it. It's the one you want to avoid, but it's the one that never goes away. So like I said, basic service monitoring is where you're just checking to make sure the host is up, the ports are available, IP addresses are correct, hard drive isn't full, RAID is there, CPU is not overloaded, you're not swapping. You know, basically the default term when you look for network monitoring anywhere. That's all you're doing with basic service. The problem is that basic service is never good because you're not doing anything proactive, you're basically just reacting. You're not looking at why things are failing, you're just fixing them when they fail. You're not looking at, are things overloaded, you're just looking at it when there's a service interruption. So you can't rely on just basic monitoring in order to tell you how you're doing, what you need to do different, and where you should go forward in the future. So what you need to monitor is performance and stats. You need to know where is your CPU load at, not is it over 100%. You need to know what the status is on the hard drives before they fail, so that way you can catch it and you can replace it in the middle of the night versus replacing it in the middle of production. You need to monitor your I/O utilization on your databases, make sure you're not getting overloaded on your subsystems there. You need to be able to monitor networks, actual performance, so that way when an ISP or a carrier or a customer says everything's fine, you can say, no, it's not, with definitive, quantifiable proof. Historical logging is always nice because then you can do things post-mortem. You don't have to catch it red-handed. And the best part is hopefully your monitoring is built into whatever your software is. So, or at least to some degree. So now that you're monitoring all these performance, now that you're monitoring all these performance statistics, you can actually offer quality, not just availability. So you can say, well, our average network time to our carriers to the internet at large is 20 milliseconds. Our average jitter is 2 milliseconds. You can have actions taken, such as restarting Asterisk when it decides to crash. You can data mine information when a customer calls up and says, I'm looking at expanding, I'm looking at doing something different, I'm looking at doubling my size. You can accurately go back and look and say, well, you'll need 2 servers, you'll need 3 servers. You should be fine. Other things you can do with that is you can actively check the customer system for loopholes that they put in it. You know, when you give the customer the ability to create phones and SIP passwords and everything, they somehow magically think nobody's going to guess 1, 2, 3, 4, test, all those other little fun things, and then they wonder why they get toll fraud. So, and the best part is you can put an SLA out there. You can guarantee a service level. What we use for our majority of our network monitoring is Icinga 2. This is different than Icinga and Nagios. It's faster, it's got a multi-threaded layout, it's a lot easier to set up. Basically, the problem that we ran into is the ability to customize a plugin. So there's a lot of different network monitoring applications out there, and I'll go over some of those in a minute. But what we really needed is the ability to custom monitor things. You know, we didn't just want to check if a web server was available. We didn't just want to check if SIP was available. We just didn't want to check if, you know, we could ping stuff. We wanted to actually know how it was performing, what our metrics were, what we were getting back. So from that, this is our Icinga 2 interface. The good part about it is it's a simple way to log in and you can see everything going on. Everything red is technically bad, but bad is a relative term. Some things like an archive server, when you have 60 terabytes and it reaches 75%, it's not quite as bad as a server with 200 gigabytes and it reaches 75%. So there's some things to take into consideration. The nice thing is this one checks about 1,500 services and it can check them all in 5 minutes. Say there's a mass exodus, which is this I've actually tested. I've walked up to the server, unplugged the NIC, and plugged it back in, and it took it 10 minutes to check every host in what's called a pedantic fashion, which is where it just obsessed over it. It was checking each one every 30 seconds, trying to find up and down. But if you have a situation where you have, 270 servers disappear all at once, you don't need network monitoring to tell you that. But it was very good, very reliable, very fast for us. Notifications, you have to tune those a little bit, but in our experience, it was pretty good. The good part about it is we do get the historical logging, so when we got a customer calling up and they're telling us, yeah, we're always having problems around this certain time of the day, we can go and we can run this report. We can see, well, according to this, around 4 to 6 o'clock in the afternoon, for some reason you seem to have pegged the CPU. What were you doing? Oh, we were doing a new business product, new campaign. Oh, did you put a bunch of extra agents on it? Well, yeah. And then you can get that information out of them. So without this, basically the customer calls up and says things are broken. With this, you can actually show where and when it was broken. And you can tell the customer, ask them what they were doing at that time. A lot of times what you run into is they had a configuration issue that they were doing. They were adding something new, doing something new, doing something beyond specs. And the best part is sometimes the alerts are comical. In other words, this one right here, what you can see is the load average was 251.64 on a quad core. And this customer wanted to know what was going wrong. I had to tell them they were dialing 800 channels through Asterisk. But it's always interesting to get this type of stuff. Some of the other network monitoring packages that we've looked at or we've tried to use is Icinga version 1, which is a Nagios fork. Icinga 1 is easier to set up than Nagios, but they're both fairly difficult to set up on their own. Their interface with the back end is temperamental, for a good way to put it. The configuration file is very convoluted at times. You don't really have much of an ability to do includes or applies. You have to kind of write rules and apply them broadly. OpenNMS we looked at. It was a little bit outside of our wheelhouse technology-wise. It used Postgre for the database and Java, both of which we don't really employ in-house. The other question I had with OpenNMS that I never got to answer is how flexible it is, how easy it is to write and develop custom plugins for it. This is a little bit of a requirement for us since we need to do beyond just basic service checks. And Zabbix looks very promising for us, but we don't really know what its expandability or scalability is at this point. It looks good. We're planning to do some tests with it, but I'm not sure how I can put my own custom plugins in it just yet. So there's a lot of other solutions out there, and there's also a lot of paid-for solutions out there. They all vary in terms of what you can monitor, how you can monitor. Some of them require agents, some of them don't require agents. Some of them have a very specialized interface to them. And a lot of them seem to have some sort of a dual license where you get a basic feature set, and then if you wanted to do more, you have to get an upgraded license for it. The other thing we did is where we added monitoring directly into the Asterisk, or the software stack itself. So we use the AMI of Asterisk, and we'll have different outputs. One's going to show us all events. One AMI login is just going to take commands. And that way we can monitor directly what Asterisk is doing, how it's doing it, the status of channels, when channels are placed, when channels are hung up, length of calls, length of attempts. We're able to get this information out of the customer's database and monitor that ourselves to see if we're having any carrier issues. The performance logging is built into the application so the client can actually do some of these checks themselves. Whether or not they necessarily understand what they're looking at is up for debate, but it is there. And we also check our time internally against the database and the web server. Here's what one of those graphs looks like where it's logged internally. The reason we log it internally instead of with an external service is because that process is already there gathering all that information, so it's easier to pull it out of the database than to duplicate it on an external system. In this particular example, in the process of 3 hours, the customer placed 21,000 phone calls. They were averaging, the red line is the number of processes, the greenish or orange line at the bottom was the number of system processes. The blue line is the load, and the green line that you see there is the number of channels. So they were averaging anywhere from 100 to 130 channels during this 3-hour span. Average channel in use was 88 across the entire system, but they had that dip there where they went to lunch. So once you get outside of just monitoring Asterisk, which is fine in of itself, the real problem comes into play with, like I said, you have to prove to customers and clients and carriers and everybody in the middle, sometimes even your own data center guys, that there is a legitimate network issue. Now, how do you do that other than reactively? In other words, how do you find that before it finds you? So what we found is a program called Smokeping, and there's a couple alternatives, but most of them are paid for from what I remember. It's a scalable distributed architecture layout. It uses a standard RRD backend to log the data, which if anybody's used what's called MRTG or Cacti or any of those, they all use an RRD backend to do their logging. Measures latency and packet loss. It also measures jitter across a 5-minute span. That's basically the only way we found to definitively prove to a client and an ISP that you have an issue. Here is your issue. And once we send them that, 99% of the time they just go, oh, okay. And then they go and they pursue the issue. They don't go down this path of, nope, everything's great. We don't see a problem. We can ping it and we don't get packet loss. By default, it logs a data point is a 5-minute span of time, and it does 20 checks to create that data point within that span. So every 20 seconds or so, it's generating a ping, an ICMP ping. Uses fping, which is fast and scalable. A lot of packages use fping to do their network latency, and it's simple. Here's what the interface looks like. The auto-generated that you see here is where we pull the customer's database from within the application to find all the IP addresses that they have SIP or IAX phones registered from. So whether the customer has one router or they have 20 people logging in from their home internet all over the place. Every night we connect to the database, we mine through that application to see where they're connecting from, and then we generate automated configs for this. That way tomorrow, when the customer calls us up and says, yeah, this client or this one user is reporting a bad problem, we can log in, we can look at what IP that phone that the user is using is connecting from. We can go to this, and then we can see if it's a network-related issue. Here's an example of where the customer was telling me, everything's fine, everything's fine. Now, the way you read this graph is the green here means there was no packet loss. Now, everywhere you don't see green, there was packet loss. And where you see purple, it was 50%. So this client, while they would call us up and they would say, well, I can get to Google. I can ping you. I can check my email. Their SIP phone sounded horrible, absolutely horrible. And when we looked up, the reason why is they were having anywhere from 10 to 50% packet loss across, what is this, a 4-hour span of time. And down here on a 30-hour graph, we can see where it reoccurs. So now we know they have some sort of a network issue. Either they have something going on in the background in their network that is just killing their bandwidth, their ISP is killing their bandwidth, something somewhere is going on, but we can show over time that there's a pattern to this. It happens every day at this time. The other thing is you see the lines here, see where it looks like a little smoke rising? That's a measure of jitter. The taller the line, the higher the jitter, and the darker the line, the more occurrences of it occurred. In other words, like right here, 250 milliseconds. This customer probably has agents in the Philippines, which is why this is so bad. But you know, this represents about 250 milliseconds. Now at this data point, it went up to probably 350 at one point. So at this particular 5-minute interval, the latency jitter was bad enough that there was 150 milliseconds of noticeable jitter in a 5-minute span. So this is something that has been very invaluable to us. The simple ability to look at a customer's network without having to install agents on their side, without having to own anything behind their firewall, without having to touch their network really. The downside obviously is we can only get to the router or whatever's in front of it, but usually that's all you need. 9 times out of 10, hopefully, their internal network isn't a complete and total mess, but that's not unheard of either. So this is one of the things that gets overlooked a lot when people talk about network monitoring with Asterisk. It's not just monitoring Asterisk. You need to monitor externally to Asterisk. You need to monitor what you're going to, what you're going towards. And this has been a very invaluable tool for us. Now, the angry customer monitoring, like I said, it's always there whether you like it or not. So it is the best form of quality monitoring because they're the ones who are actually using it. So they're always going to call you whenever there's a problem. It's often the hardest to quantify as well because, you know, the customer always calls up and, you know, it's the copier turned on and that's what caused the performance of Asterisk to go down. So you have to take it with a grain of salt when they call in. Now, you should never dismiss a customer complaint because they're not calling for the fun of it usually. Everybody has had one of those, but usually they're calling because there's a legitimate issue. They just don't know what it is or don't know how to explain it right. So you should never assume the customer's wrong, but never assume they're right either. Most customers like knowing that you can show them graphs, that I can send them that image of Smokeping and say, well, here's where your network is bad, so I can prove that you have a network issue. They like that. They don't want the finger pointing. They don't want you on the phone going, well, it must be your network, and then the carrier's on the other side of the line going, well, it must be your provider. It must be your hosted provider. They don't want that. They want definitive, just like you. If you had an issue with something and you called up a vendor, would you want them to start pointing fingers? Do you want them to say, here's the issue, here's the problem, here's what you need to go look at? So they want the same thing you do. So that's why angry customer monitoring is a valuable thing. Now, some observations I've had along the way is that Asterisk monitoring it with the Res SNMP module is not necessarily reliable for us. We've ran into issues with it responding, not responding. Today it works, tomorrow it doesn't work after a reboot. So we've kind of given up on SNMP, which is why we needed the custom plugins so we could connect directly to the AMI in order to get our information and parse that information out from channel listings. You should always try to use the solutions that have a technology base you're familiar with. So if you are a Postgre and Java shop, then OpenNMS is what you're going to want to use. You're not going to use something you're not familiar with that you got to go seek outside help with. When we started to do this, we tried to have one software package to rule them all, kind of like that Lord of the Rings approach. The problem with that is if it generally does everything, it generally does it bad. So we've given up on that and have realized that you need to find something that does what you need it to do exactly. Only then will you be happy with the results. Sometimes that may mean you need 3 or 4 packages, but that is what it will take. So hopefully you can find something that allows you to do some level of integration so you can kind of tie them together and get something cohesive. An active developer community is invaluable. There's nothing like finding something and saying, this software package is great, and then you have one key question that makes it a make or break for you. And then nothing, everything's silent. You can't get an answer on that to save your life. You can't even pay people to give you an answer. That's the one that truly astounds me. You call people up and say, I'll pay whatever exorbitant rate you want to answer this developer question. They go, I kind of quit playing with it a year ago. So that's the one thing you really need to look for. Easy plugins. You need to have something that has an easy method for you to write and develop a plugin for it so you can add these active checks. So whatever you're monitoring with Asterisk or outside of Asterisk, thought I told it not to go to sleep. You need to be able to make sure that you can add that, or you need to be able to customize what's there. The ability to work in a distributed fashion. This has more to do when you start to scale. You need to be able to keep the performance up. So one of the problems we had with Icinga 1 and Nagios is when we got up to around 100 hosts, it would take it sometimes 15 minutes to check all the services. Well, 15 minutes of downtime on an Asterisk cluster is not good. You want to know when something happens within a minute, because then you can correct it and fire it back up. 9 times out of 10, the customer will go, oh, it's back up, and they're happy. They're fine. They don't need to call you. But if they have to call you after 10 or 15 minutes, then they're going to be an angry customer. And there is no right or wrong approach to any of this. So it's really about what is going to work for you and what is going to make your customers the happiest. So that's kind of my presentation, not very long. Hopefully there was some good information in there. Anybody have any questions on how we did it or approaches we used? Yes? Smokeping works in a distributed fashion, so you can either run it as a one instance locally, or you can have a master and slave zones spread around it. It does not use anything special. It operates Perl CGI, so you use mod CGI with Apache. It uses fping locally. Truly the hardest part about configuring Smokeping is getting the CGI to play right because it uses fast CGI. So you have to enable fast CGI in Apache and get that working. Once you get that working, the configuration file layout's actually pretty simple. So. Smokeping is ICMP, so it's a standard ICMP type of ping. So for monitoring SIP, we do that in the application from the AMI. So we'll actually look for lagged messages or disconnected messages through the AMI, and then that's what we'll use to judge within the application whether or not a client phone has come up or come down. So, any other questions? Yes. Pardon? Yeah, this report right here, if you look in the upper left-hand corner right here, you can put in search criteria. So you can tell it to show you a span over a day, and then you'll be able to look at that and you'll get an idea of how many channels. In other words, this customer's max channels was somewhere around right here, which is around 250. So it'll give you an approximation because it's a graph, but you could pull the database directly if you wanted to get that. There's also a different report, which is all just numbers and text. That will give you that, but it's far less pretty than this, which is why I put it in the presentation. So, right, this is one example of where we're doing monitoring within the application, because then we can monitor exactly what we need for that application. So instead of trying to guess this from the externally, although I do have an AMI plugin that I use with Icinga 2, but it just gives me basic channel count. So it'll tell me total channels, how many SIP channels, EEX channels, DOTI channels, and local channels. And what I'm monitoring there is I'm just monitoring total channels. I'm not monitoring individual calls. I'm not monitoring things like that as far as my alerting. I just want to know when Asterisk goes over 400 total channels, because then I need to step in to see what's going on, because that's where Asterisk starts to crash, regardless of how much hardware you throw at it. You start to run into more of a issue with deadlocks and parallelization within the software. So, yes? With the AMI? 1.4 and 1.2, or 1.4 and 1.8, not too bad, because they're mostly the same for a large part of the commands. There's a few that have changed, but like from 1.8 to 11 or 10 is different, and 1.2 to 1.4 is different. You can run into issues with the AMI when you're monitoring from the AMI, where when Asterisk gets overloaded, it will stop throwing events to the AMI. So you'll be listening on an AMI looking for something, and it may just never show. That usually only happens at high load. Like I said, when you get above 400 channels, that's one of the things you start seeing. You start seeing issues with codec negotiation, where it will negotiate a codec and then be using a different codec on the channel. But that's usually a lot harder than what most Asterisk is pushed to. How many people in here use Asterisk in a call center, like in an outbound capacity? See, we got one guy, two guys. So they are probably familiar with some of the things I'm talking about, but it's a different ballgame. You start pushing Asterisk at load for outbound. But the AMI has generally been pretty good for us. Any other questions? Yes. Sorry? Yeah. Depending upon how fast you're dialing, how quick you're incrementing the internal counters in Asterisk, some clients, as a rule of thumb, the way we tell it to clients is there's two methods to handling Asterisk's eventuality of crashing. You can either do it in a controlled manner, which is a reboot at 5 a.m. in the morning, which nobody's ever going to notice, or you can do it in the middle of production, which is when it crashes. It doesn't crash in the morning when nobody's on it. It only crashes when you have everybody logged into it and you're pushing channels through it. So, but beyond that, depending upon how hard you're using Asterisk, you can run anywhere from, like in an outbound dialer capacity, or even like click to dial, anywhere from a week to maybe a month, depending on what you're doing. If you're doing predictive dialing with it, where you're, the system's automatically dialing 150 phone lines all the time for 15 agents that are logged into it, you're going to want to reboot it every night. What you'll just run into is it'll lose track of local channel resolution, so it'll place a call and it'll forget what channel that call was on, so you'll lose track of it there. You'll run into the AMI issue where it's not firing events to the AMI, so now you don't know what the status of anything is. So, yes? Oops. We've tried doing that. The problem is getting something that's the same every time, like 1.4 versus 1.8. They may have different responses to different things. So what you would then have to do is put something in the dial plan to actually give you a certain response, and then getting 1.4 to give the same response. Like with 1.8, you can actually set a SIP response code, and you can get that back. You can't really do that with 1.4, so you got to kind of use something like congestion, and in congestion, maybe a 4.86, maybe a 4.87, maybe something, depending on what version of 1.4. So typically what we'll do is we'll check the SIP port that we can send a SIP options to it, and that we get some response. If we get some response, then we know SIP is working. That's generally how we do our heartbeat checking of SIP. IAX, we don't worry about too much. Almost nobody really uses IAX anymore, and we only use it between the servers because it's more efficient. Less load, less processor load in Asterisk. Any other questions? Yes?
How do you make scalability for
Which aspect?
Well, I mean, I had to do a first trial with a client who's one of
Congratulations, and I'm sorry.
and you know, in Asterisk died 400%, right? So I mean,
Right. Within the VCDIAL application itself, the way we addressed Asterisk scaling issues is we designed it to scale horizontally. So, you know, you don't throw bigger, better hardware at it, because once you max out a quad core, chances are Asterisk is going to crash on its own anyway. You know, so the ability to use a 6 or 8 or 24 core machine, like I had one client call us up with, it's just not there within Asterisk. It just doesn't scale to that level. It's not Apache or MySQL as far as its ability to thread. So what we do is we design it to scale horizontally. So the back-end processes of VCDIAL will break up how many calls it thinks it needs to make on the database and assign calls to individual servers. And then there's a Perl process that runs on the individual servers that gets that list of calls, connects to the AMI, and issues dial commands through Asterisk. So that was our approach to it. So there's a couple of background Perl daemons that kind of handle distributing the load across, which is why getting reliable AMI events is so critical for us, because if we don't get those events, we don't know what's actually going on within the core of Asterisk itself. Any other questions? Yes? Well, 400 is just a rule of thumb. Depending upon how you're doing it, you can run a higher number of channels. The critical piece within Asterisk as far as channel load is this setup and teardown. That's the truly expensive part. You know, once a call is placed, Asterisk does nothing other than shuffle packets for the audio. So there's really nothing for it to lock. The problem is when you're doing calls per second. When you start doing 15, 20, 30 calls per second, that's where you run into an issue with Asterisk. Because that's the part where this thread will lock one piece, this thread will lock the other piece, and now they're waiting on the other thread to come undone, which is a deadlock. So that's kind of the issue you run into. It's more of how quick you're dialing, how fast you're placing calls, and how fast you're hanging them up. Once the call is placed, it really doesn't have much of an issue outside of its ability to shuffle packets back and forth, or transcoding. You're trying to go from G729 to ULAW, which it moves you to IO bound. Yes?
I mean, you know, one of the things that makes the dial with the ASR is so low.
Oh, yeah.
I mean, it's a very different traffic pattern.
Yeah,
And all of these hanging calls, you know, ran, don't go anywhere without an end.
right. And then the problem with doing that with SIP as a protocol, which isn't an Asterisk issue, is you potentially have to keep a SIP dialog open for 20, 30 seconds after you place it in order for post-SIP garbage to come through the line. So you've already hung up, you've already issued what's called your buy, but you're still just holding on to this session, chewing a chunk of memory up, just in case something else comes through, just so you can respond to it. And that's usually around 20 to 30 seconds, depending upon the SIP stack. So that's something else that causes the bloat, that causes the deadlock issues. Eventually you just get kind of this memory pool that just keeps creeping up and it just eventually at some point loses track and never goes down. So even if you kill Asterisk and start it up again, it still kind of has a shared memory lock out there that's kind of messing stuff up. Any other questions? Yep. We actually have a second location. So we have one location located in Tampa, Florida, and then we have a second location connected by a point-to-point link in Columbus, Ohio. So, you know, that way if, say for some reason, a Category 5 hurricane comes through and cuts Florida right in half where we're at, we have a backup location in Columbus. We have a second set of archive servers. We have infrastructure up there, so that way we can put up a website. We have our client data there. There is no loss of data, and we can get clients running in some fashion while we put more servers into that location. Some of our clients actually pay for the privilege of having a redundant setup, which is, you know, why buy one when you can get two for twice the price? Unfortunately, not all the clients like that idea, so some of them are happy knowing that we have backups of their data, of their recordings, that we can get it to them, and that we can get them up and running again in a week. And the other clients who want to pay the extra money, like, no, we can get them up and running in 5 minutes. So that's currently how we manage that. And that's, again, monitored through rsync, and basically on the archive servers that do the seeding, I'll put a little file in there with a little, basically kind of like a timestamp, and then I'll check that it gets seeded through to the other servers, and that's how I check that they're current. So, yes? Mm-hmm. Kind of a nature of the beast. We noticed that when we moved from 1.4 to 1.8, the average load for the same workload itself was higher with 1.8 than with 1.4. We did notice with 1.8 that we didn't have spikes as much. So with 1.4, you'd be running along, and then you'd double your CPU load for 30 seconds and it'd drop back down, and you just keep running. With 1.8, it's just generally higher across the board. They both seem to handle relatively the same load. They just kind of have different profiles for how they load the system. 11 we haven't messed too much with. It's on our plans, but there's too much feature development being done at the moment. So we don't really want to modify the application to work around something where a feature may change, it may be deprecated, it may be added to. So we kind of wait until the long-term support Asterisk get put into maintenance or security and patch and fix, bug fix mode before we really start looking at it. But 11 looks promising, but we haven't done extensive testing with it other than installing it and go, oh, that looks nice. So, any other questions? No. I guess that's it. I think that's my, yep. It's my 30 minutes.